Okay, good morning to you guys at home. Good morning to you guys here. We are working with what we call integration by substitution. Now, I'm going to do a couple of things here so people know. Let's go to the website, and you're not 125, so we're going to get out of there. All right. We're going to go to Math 261. Where are we at? Come on, let's go home, I guess. We have Math 261 here. Worksheets and videos, Math 261. Now, what I have online is integration by substitution. This assumes you already know how to do integration, already. So it assumes you know about antiderivatives and properties. Everything we've been working on. Okay, and so here's kind of the worksheet, and let me see if I have that here in my notes. I think I do. Okay, so there is notes here on this process, and not only is there notes, I even have a video over all those examples on use substitution as well here. Okay, so it's playing there, but I'm not going to play the video. So you guys actually have that here for you. 2.5 hours of videos on how to do those examples on that particular worksheet. I'm going to do different examples today for you guys. Okay, because I think a variety of examples is probably the key here. That's my opinion. But I'm going to go back to this worksheet to kind of describe to you what you're doing here. This is based on, if you guys notice right in here, okay, this is composition of functions, okay? So you're really going to do you really have to recall composition of functions. You have an inside function. I'm going to say to you, I'm going to put this, I don't want to, what color do we use? Whatever. Inside function called G. Okay, and I think I use red because I want people to understand that part. You got the inside function, and you have the outside function in composition. Okay, so this is what I'm saying to you guys. If you remember fog, that infamous concept of fog, you got the inside function there. You got the outside. So the inside function is G. The outside function is F. I want you guys to remember this is kind of the analog to chain rule. So it's the analog to chain rule. Okay, you guys okay with that? All right. So we're going to identify an inside function and an outside function. So what I have personally as our first example, this is going to be a whole different set of questions than on that worksheet and on that video, because it's good to have a variety, okay? So you have more examples of this procedure than any other calculus students at this school and any other school. More examples, because I have 3.5 hours or whatever that was, 2.5 hours of one set of examples. You're going to have some more of another set. A lot of examples. Okay. So do you guys remember chain rule? You had the inside function and outside function, right? You guys remember what I'm saying? You had f of g of x in chain rule, right? So remember, for chain rule, wasn't the inside function what was between the parentheses, ladies and gentlemen? Do you guys see what I'm saying? The inside function was what's in the parentheses, and the outside function was this power, right? So this is the F that I'm saying here. And that was what we looked at for chain rule. So it's composition now for integration. Now here's really what you do, okay? You see that red, the inside function? Here's the process of substitution. you let u be the inside function here. It's the function in red. Okay? Now here's step number 1 here. So let u be the inside function. So I'm going to move this out here. You do have that notes. You can follow the notes. It's the same thing. But we're going to tell you u is the inside function. Okay? That's what u is. Now, once you let u be the inside function, here's step number 2. Step 2 in the notes says this. You're going to always, always, always determine du dx. Now you say, what do you mean by that? Determine du dx. Well, you're going to differentiate the u function with respect to x. Now, remember, what's the u function? It's x minus 3. So you're going to differentiate that. Okay? You guys okay with that? Well, what does this give you? You guys know, what's the derivative of x minus 3? That's 1. So what you just found is that du dx equals what? 1. That's what this equals. Okay, this is step 1. Let u be the inside function. Differentiate u with respect to x. We just did. Here's step 3. Solve for dx. Okay? You're going to do this procedure every single time here. Now, you say, well, what am I looking at? Well, what you're looking at here, I'm going to rewrite it, okay? That du dx is 1. How do you guys solve for dx? Do you guys know you're looking at a proportion? Okay, du dx is 1 over 1 as a proportion. How do you solve a proportion? Do you guys remember? You're looking at a proportion. You say, what do you mean? A over B equals what? C over D. So solving a proportion, ladies and gentlemen, means AD is BC. You cross multiply. Okay? So that means you have du times 1 equals what? Dx times 1. Or you have du is dx. Okay? So far, so good? This is a 3-step process here. Yes, it's in my notes, but I'm going to deviate from that. I'm going to give you guys a whole other set of resources here. So you got an abundance of examples for you. Now, here's the thing that you do in step number 4. Okay? Step 4, you substitute. This is why they call this substitution. And in fact, it's known as u substitution. So go back to the original question. X minus 3 to the 5th power dx. Right? So what do you think this becomes? Right? Here's what I mean by that. What do we just call, for example, the inside function? What was that? That's u. Is that true? Okay. And what did you just solve for? You just solved for dx. Can you guys tell me what dx is? Dx is what? du. So what you're really looking at is u to the 5th power du. this is what you need to integrate now. Okay? So you have to integrate u to the 5th power. What do you guys do to do that? Anybody know what that integral is? What's that answer? Is 1/6 u to the 6th plus c. So you guys actually did that when? Yesterday. So this is here anti what? Derivatives. This is why I say you got to know your antiderivatives like you know your name, because now we kicked it up. This is u sub. Because if you said, you know what, I rather do, Mr. Judge, is I'm gonna do the algebra on x to the 5th power. I got to use FOIL. I'll say good luck. How long will that take you? Very long time. What if the power was 10 or the power was 12? You guys see what I'm saying? You got a new technique. So now what you have here is this. Go back. You say, did we just find that this is really 1/6 u to the 6 plus c? Is that right? Well, you're integrating with respect to the function x. You're not integrating necessarily with respect to u. So your answer has to be in terms of x. So my question to you guys is this. How do we get the answer in terms of x? What do we use? Do you guys know? What do we know about u? How is u defined? X minus 3. So this here is what? X minus 3. This is the same exact u, okay? So ladies and gentlemen, you're done. You say, how am I done? Here's your final answer. It's really 1/6 x to the minus 3 to the 6th power plus c. There you go. Easy breezy, lemon squeezy. Ladies and gentlemen, you're done. There's your process. It's the 4-step process here. And so you just repeat this process over and over again. And this is the chain rule version of a derivative, the analog. It's now chain rule of integration. Okay, because again, here you'd have to use algebra, FOIL, but if you use u sub, what do we let u be here now? Remember this? U is the what? Inside function. So you say, oh, are we going to let u be, what is it going to be now? 2x plus 5? Okay, you guys okay with that? So here's that first step again in u sub. What's the second step that you do? You guys want to remember this process because you're going to see this process when? When's your next test? Did we talk about that? I don't think we even got to that, did we? Oh my gosh, let's go back. That's not you. This is not you. Oh, we got to go home, I guess. 261. The next test you guys have, which you'll have u substitution on the schedule, is on what day? This is on Monday, ladies and gentlemen. Monday is your next exam here. Monday, let's see. This is December 5th. I see that. So what do you think will be there? U sub. All right. So step number 2, what do you guys do? Differentiate u. What is u? 2x plus 5 with respect to x. What's that derivative? Do you guys know? 2. So you say, what does that mean? It means that du dx is the value 2. Okay. Now, what is step number 3? If you guys remember step 3, solve for dx. Now, how do you have to solve for dx? Cross multiplication, because you have a proportion, okay? So this means du times 1 is 2 times dx. What is dx? Dx is du over 2, okay? So the most important steps I would say to you guys is this. This integral is really going to be now what? You see this integral? We say what? Substitute now. U to the third power. What is dx? Du divided by 2. So in this step now, we substitute here. Okay, u to the third, du over 2. Okay, you guys okay with that? Easy breezy? What do you guys know about this du over 2, though? That's a what? Isn't that a constant? So I can pull out constants. That constant is 1/2. And we integrate u to the third, du. There you go. So we converted to another integral as a function of u. What do you guys use now? What do you guys remember? Keep your constant. Power rule, isn't that 1/4 u to the 4th plus c when you integrate? Okay, and what does that give you? 1/8 u to the 4th plus c. What is u again? Because in some ways you're done, but remember, if they give you a function of x to integrate, you got to give a function of x as an answer. So what was u, ladies and gentlemen? You guys remember what u was? What is u again? Yep, go back to your first step. It's 2x plus 5. Ladies and gentlemen, you are using, again, what? The process known as u substitution. Okay? There you guys go. Easy breezy, lemon squeezy. What happens now with this one? What do you guys think? What happens here? What's u going to be again? Just like chain rule. 3 minus x. Good. First step, okay? All right. And then second step. Differentiate the u with respect to x. What's this derivative going to be? Do you guys know? Isn't that -1? So that means du dx is what? -1 here. Okay? -1 over 1. So it's du times 1, -1 times dx. So you get du equals negative what? Dx. Okay, now you didn't solve for dx. What does dx equal? Dx is minus du. So we care about this dx. We care about u. Because now we get to what? Substitute. Okay, you guys see what I'm saying? We substitute. Okay, what does the substitution become? This is really the integral of what? U squared, and dx is minus du. Okay? We can pull out our constant of what? -1. We get negative integral u squared du. Okay? This is what we're now going to have to use for power rule to integrate. Okay, but don't forget you have a constant out here called what? -1. Okay, so that's going to equal negative, what's this? 1/3 u to the third power plus c. You did your antiderivative homework, your indefinite integral homework stuff. You're almost there. You just have to tell me what you said u was to begin with. What is u? 3 minus x. So, ladies and gentlemen, final answer is going to be -1/3 3 minus x to the third power plus your constant c. And ladies and gentlemen, you're on your way. You're integrating with this new technique called substitution, for short but long, u substitution, or I should say specifically u sub. There we go. What do you guys think? Is that easy breezy, lemon squeezy? It's not too bad. Whew. Boy, we could do this all day. Look at this. Just like chain rule, remember? We got this portion is going to be our what? U. So let u be what? 5 minus 2x. Okay. What's the second step? Right? We do du dx. Maybe I should put that step here. The detail. And then this is going to be what? Isn't this -2? So du dx is -2. If you write this as a proportion, you get to cross multiply because at this point you solve for dx. Is that right? So what does dx give you now, right? We say what? Du times 1 is -2 times what? dx. Du is -2 dx. We're supposed to solve, what is that? We're supposed to solve for dx. So how do you guys solve for dx? Do you guys know? You divide both sides by -2, so it cancels, right? So what's your dx? Dx is du over -2. We need that, and we need what? U. There you go, ladies and gentlemen. Okay, so how do I use this now? Do you guys remember? What do we do? This is really the integral of u to the fourth du over -2 now. Okay, don't forget, because you say, I have that fourth power here. Remember that? What's the -2, though? Isn't that a constant? You pull out constants. It's -1/2. U to the fourth now. Du. And this is where your homework comes in. Okay? -1/2 u to the fourth du here. What do you guys use to get this answer? Do you guys remember? You're going to use what here? Power rule. That's 1/5 u to the fifth plus c, and then you multiply your fractions, and that'll give you -1/10 u to the fifth plus c. You just have to remember what u was to get this final answer. What was u? 5 minus 2x. Good job. All right. So you'll say, okay, is that -1/10 u? 5 minus 2x to the fifth power plus c. It sure is. So ladies and gentlemen, there you go. You have an answer there. Easy breezy lemon squeezy. guys think? Pretty good? Yeah, it's right here. This is the negative 1/2 down here, okay? So when you went back and you said, well, what did I do? Remember, this is your dx. Your dx is this. It's du over -2. So you're going back up to the original integral and you're substituting. This is going to be here. This is at u, and that was the du over -2 here. Don't forget you have the power 4. And so that's how you do the process. So yes, you always have to put the dx there. That's only half. That's like half the substitution. So this is why I emphasize in red. Here's my u, and then I emphasize in blue. Here's my dx. Those two things are a part of the substitution process. Yeah, you can't finish it without either. This, just like for chain rule, do you guys remember what u was again? You say there's no parentheses, but it's under the what? Under the radical. This is my u. So just like for chain rule, if we had to differentiate, you would say u is x minus 2. Okay, so that's the first step again. But you would say to me, you know what, Mr. Judge, I think I already know what I'm going to do. I'm going to skip steps. You say, is this going to be the square root of that u? And I'll say, yes, it is. But don't ever forget, what is this? You have a dx. So you can't integrate a function u if you have dx. You got a problem here. Remember, u is a function of x, but you changed the variable. You went from an x variable to a u variable. So this here must always be a du. Okay? But then you say, well, how do I get it? You get it by the second step. Because du dx requires you to differentiate with respect to x that u. And what do you know? What's the derivative of x minus 2? 1. So what we're doing in the second step is we're saying du dx is 1. Don't forget that's 1 over 1. And now what do you do here? You cross multiply, and what does that mean? Your du happens to be what? Dx. It's the same thing, okay? So you must get that second portion. You have to. So now you say, oh, is that the same? Yeah, du is dx. So I can just replace that dx with what? Du. And now you recall this is really u to the what? 1/2 du. Now we can integrate, okay? So what was that again? Do you guys remember? What's 1/2 plus 1? 1/2 plus 1 is 1/2 plus 2/2. Isn't that 3/2? You say divided by 3/2 plus c. We've seen this. But that's really 2/3 what? U to the 3/2 plus c. And you said, you showed me, Mr. Judge, that this is 1/2 plus c. Remember that simplification? Okay. So what is u, though? Isn't u x minus 2? Right? U is x minus 2, isn't it? So final answer, here's what you guys can see in back of the book. Say that's x minus 2, square root of x minus 2 plus that c here. So ladies and gentlemen, yeah, there it is. There you go. Okay. So you always let u be the inside function. Like in this case, what's the inside function? It's 3x plus 2. So you can say, oh, we're going to let u be what? 3x plus 2. But remember, if you started to do your substitution now, I don't. Yes, that's a square root of u, but you still have the dx, okay? So be careful here. This is why that second step is to find that dx, meaning they say differentiate u with respect to x. Find du dx. Which is going to be what? What does this equal? 3. You say, can I put it as 3 over 1? Yes. Because the whole idea now is for you to find what? Dx. You got a proportion now, cross multiply. So it looks like it's du times 1 is what? 3 times the dx. So you got du is 3 dx, but we need dx, ladies and gentlemen. Okay, how do you do that now? You do what? Divide both sides by 3 here, and you end up with du over 3 equals what? Dx. Okay, so you're going to replace this dx with, what does it be? What do you get replace it with? See what it is? What is dx anyway? It's du over 3. Oh, okay. So this is really du over 3. Okay, don't forget, constants gets pulled out. So if he said, is this really going to be 1/3 the integral of the square root of u du? It is, which is really 1/3 the integral of u to the 1/2 du. This is where you what? Integrate. One-third. What's 1/2 plus 1? 3/2. So you integrate, don't forget, plus c. And then this becomes 1/3 times what? 2/3. U to the 3/2 plus c. So when you multiply fractions, it's 2/9. You now simplify the u to the third, u to the what? 3/2. Remember this? As a mixed number is 1.5. It's that trick again we've been doing all along. You just have to remember what u was. What was u anyway to begin with? 3x plus 2. Two ninths. 3x plus 2. Square root. 3x plus 2 plus c. Here you are, ladies and gentlemen. There it is. Number 6. Easy breezy, lemon squeezy. Use substitution. What do you guys think? What do you think? What are we going to do now with our u? What is u? U is an inside function. If this was a derivative, isn't u 1 minus x? If you had to use chain rule, you're going to say u is that 1 minus x. Is that right? And yes, I'm not saying you want to substitute now, but I want you guys to see this point here. Okay? You called this thing u. du dx becomes d dx. U is 1 minus x. What's this derivative? Do you guys know what that derivative is? Isn't that negative 1? Okay. So that your du dx is negative 1, but divide by 1 if you need to see a proportion, if you need to see that so you know to cross multiply, because the whole idea is to solve for what? Dx. The whole idea is to use that u, and you did. So let's find what this is. This is going to be 1 times du, negative 1 times dx. This will be du over negative dx. Be careful. I'm going to go back over here and remind people that you have to solve for dx. So you always divide by the number since you're solving for the dx. That's multiplied to it. So it cancels. Is that right? So notice this becomes what? What is your dx? Yeah, dx will be what? Negative du. So that's what you're looking for. Okay? So dx is that negative du. That's the information you need. So you said, what did I find? You found that dx. It's negative du because this is what you're looking for. So that integral, notice the integral here. Yes, it is. Take out that constant, negative 1 over the square root of u, what? Du. Okay, because you pulled out your constant of negative 1. Now what's the deal? Negative u to the minus 1/2 du. So this is going to be what you need to integrate here. Okay? And we've been integrating that over and over again, haven't we? Right? What's negative 1/2 plus 1? Isn't it positive 1/2? I think so. So this will be u to the positive 1/2 divided by positive 1/2. Don't forget that negative 1 constant's there. And doesn't that make that negative 2 square root of u plus c now? Okay, you guys okay with that? But you know what u is. U is 1 minus x. So there you go. Easy breezy lemon squeezy. Should we have you guys try number 8? How is number 8 different? Let me share this with you guys, right? What is this here? You guys notice what's going on here at first? You got a constant. What do? Take it out. Good. And now you have 5x plus 3 dx, right? So, okay. All right, what's your u? Do you guys want to tell me what u is? U is going to be the what? What's under the radical. Okay, because like if you had to do chain rule for differentiation, that's the inside function. So notice the process is the same, even though you pulled out a what? A constant to start, so that's okay. All right, next step again. You say, what's the next step? Differentiate u with respect to x. So this is du dx, which is differentiating what? 5x plus 3. And what's that derivative? That's 5. Is that right? So even if you put this as a proportion, because you know we're going to have to ultimately what? Solve for dx. And you do that by cross multiplication. So du times 1 is 5 times dx, right? So you're solving for dx. That means you divide both sides by 5 here. So you get cancellation. So at the end of the day, dx is really just du over the number 5 here, okay? So you're finding the two important pieces in u substitution. You let what ub is, which is the inside function for composition of functions, and you found dx. So now when you go back to that integral, yes, you already have 4, and you're integrating 1 over the square root of u. Now you have du over 5, okay? You replace that dx with du over 5. Yes, you have another constant that you pull out. So you say, does that now give me, you now have what? 4/5, ladies and gentlemen. Integrating u to the minus 1/2 again. Okay, so here's going to be where you what? Where you integrate. Power rule again. Adding fractions. 4/5. Right? Negative 1/2 plus 1 is positive 1/2. And then it's 4/5 times 2 over 1. You do the 1/2 plus c. We now get 8/5. U to the 1/2 plus c. So what does this become with our u? What does our u say? Isn't u 5x plus 3? Here we go. 8/5. Oh no, it's 5x plus 3. Okay, not c. Is that right? And so in some ways, here's your answer. But if you're looking back at the book, you might say they showed square root 5x plus 3. So here you go, ladies and gentlemen. There it is. So what do you guys think? Are you starting to get a good feel for the pattern of what's going on here? Right? What do you guys think? What about this one? What do you guys know about u? What is u going to be? Whatever's under that radical, okay? Now, don't forget, this is going to be, you got the power here, or not the power, you got the index of 3. Okay, so even if you said that looks like it's the cube root of u, well, it is a cube root of u. Don't forget you have dx, though. So you need the second step, which is du, dx. You're going to differentiate the x minus 5, and you guys know that's 1. So writing this du dx as a proportion, because you got to solve for dx, it's down in the denominator position. We got to plug in that dx. And what do you guys notice? What do you get? Again, in this case, du is the same as what? Dx. So you say, well, that's pretty simple. Just change that dx to what? Du, and now you got u to the 1/3 du. Now you can integrate in terms of your variable u. Okay, you need that variable u. All right, here you go. What do you guys do next? What's 1/3 plus 1 by power rule? Isn't that 1/3 plus 3/3, which is 4/3? So you're going to get u to the what? 4/3 divided by 4/3 plus c, or 3/4 u to the 4/3. I'm going to do some simplification now. Right? This is what? 3/4 u times u to the 1/3. Is that true? Right? Do you guys know what I'm talking about? Is that u to the 1? What did I do? Isn't 4/3 as a mixed number? 4/3 is really what? 1 and 1/3. True? I would say to you, I mean, like if you wrote your answer, go back to C. What is u, right? It's x minus 5. Personally, if I seen an answer this way, if you said, here you go, 3/4 x minus 5 to the 4/3 power plus c. If you wrote it that way, I wouldn't mark it wrong. You know, I wouldn't. But what I sometimes get is when students looking back at the book, this kept them up at night. They're going to say, I don't understand why this is my answer. Okay? They're equivalent. So, you know, what I've done here is demonstrate to people, well, I used to just say, well, they simplified the they simplified the rational exponent. You say, what's a rational exponent? It's a fraction power. They simplified it. So this kind of has kept some people up at night, which is why I go through this and say, okay, well, I'll just let you know what that is now, and then you know the correct answer in back of the book. But would I say, no, 4/3? No, I would mark it right. That's fine. But, you know, I do want people to understand and go, oh, okay, that's how they got this. All right, you guys okay with that? Now let's look at number 10 is very similar. So what I've just decided to do with this new worksheet, okay, because it's new. You already have the older one when I went over U sub. Answers are there. But like I said, I decided to give you extra resources because you want to go to Calculus 2 knowing how to do U substitution like a champ. Okay? And so now du dx becomes du dx of 2x plus 5. This is just the value 2 now, right? So let's see the effect now here on this. This means du dx is 2 over 1. Remember, the idea is to solve for dx. And you got a proportion here. So this means du is really 2 dx. Okay, you're solving for dx. So divide both sides by what? 2. d over 2 is dx. Okay? All right, you guys okay with that? Integral. Isn't that cube root of u? And what was dx? du divided by 2. So don't forget, we actually solved for this. This is our dx. Right? Dx is du divided by 2. That's a vital part of this process. So remember now, you say, what is this here? This is going to be your 2. You can pull that out. And you say, is that the cube root of u du? It is. U to the 1/3, what? Du. So at this point, again, you just use your what? Power rule, adding fractions. This is all arithmetic at this point. Okay. So you say, okay, this is 1/2. And I won't do that, but let's do our arithmetic. 1/3 plus 1 is 1/3 plus 3/3. Isn't that 4/3? Okay. That's really multiplying by the reciprocal of 4/3. This power is the same, so now I get to do my arithmetic. It looks like nothing cancels here. That's 3/8. U to the 1/3 plus C. Writing that 4/3 as a mixed number, again, arithmetic, and U again, 2x plus 5. So, final answer, let's put this together. 3/8. 2x plus 5, cube root of 2x plus 5 plus that C. So a big part of the class is doing derivatives and integrals. This is integration. Okay, you guys okay with that? That's a pretty big part of what you do. The rest are just applications of integrals and derivatives, really. So this is kind of like your bread and butter, you know. And in all honesty, you know, this is why for years ago, when I would teach Calculus 2, students would come in not knowing how to do substitution, okay? You guys know what I mean? And like, what? So that's when I started videotaping. I have a whole bunch of, gosh, I got to look back. I even have a video of myself doing it back in the old days when they didn't have iPads. I brought in a video camera, and you see the old Mr. Judge there in the video camera doing some of this stuff. Anyway, pull out that constant 3, right? You know, it's kind of amazing to me. I have this meeting I was supposed to go to, like right now, and I declined. I'm not going, you know? It's a sad meeting. It's a very sad meeting. It's a heartbreaking meeting, in all honesty. It's a meeting called AB 705 meeting, and it's a whole political process. It's insane. And the extent industries do to lie to people is crazy. Because we're lied to about a lot of stuff. We're lied to there. So I'm going through this seminar. Okay, let's read how removing prerequisites is great for students. So you imagine if you took a calculus class without any algebra and trig. How would you do? Exactly. So that's the sad thing, because they don't think people can do this work. It's too hard. Anyway, if I thought that way in my life, I would never have been able to do it. I used to think that way about myself. I used to think this is something I couldn't do. Doing my homework every day changed my life. I told you guys that. So they don't think your life could be changed. They think your life's the way it's going to be forever. Without you having any ability to determine for yourself, you can do a hell of a lot more if you decided to, and you put yourself in a position to succeed. That idea is gone, ladies and gentlemen. And it doesn't benefit you. It benefits them. Do you guys see what I'm saying? That philosophy doesn't benefit students. It benefits the industry. So there was this SC doing data stuff, blah, 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 blah. Oh, it's a whole thing. I don't even want to think about it. I decided, where's the best place for me to be? Right here doing integration with USub with all of you guys. Much better to be there in this seminar of crap, in all honesty. Anyway, true story. That's why when you came in, I had the headphones on. I was like, I'm not going to get out of here. And you want to know something? When did they tell us the meeting was going to occur? Yesterday. So they even allow you to schedule or reschedule or do anything. It's like, it's the industry. They're telling you, guess what? Do it this way. And where do students go after this? You guys know where students have to go now? Really? They got to go to private schools, where they charge you like, how much was that class? Is it $451 a unit? I can't remember. They charge you like a lot of money. Crazy money. Yeah, almost $500 per unit. Yeah. Yeah, exactly. So you go, okay, I took a 5-unit class, 4-unit class, prereq, they'll offer remedial education, what they call remedial or pre-transfer. Sounds better to say pre-transfer than remedial. You have to pay thousands of dollars now for the class. That's the whole point, to get you to pay more money for this. Whatever. Okay. I think I made the right choice personally, ladies and gentlemen. I'm right here. So remember, there are people that want to make you pay a lot of money for what you're doing right now, and I'm leaving it on the internet for free. And I should say it's not free. I have to pay for that internet. School doesn't even pay for it. That website is paid by me. I have to renew every year. And then I had somebody walk in my office and they said to me, "What are you doing with all this equipment?" "Oh, I'm broadcasting, blah, 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 blah." I go, "That's like thousands of dollars in equipment." I said, "Oh, no, it wasn't. But if you included a good laptop, certainly it will be, So they looked at that and go, "Oh my God." So who pays for that again? Not the school, not the industry. It is me. Anyway. So I think I made the right choice, doing USub. So what do you guys think? What is your inside function again? It's whatever's in the parentheses. X plus 1. That's the U, right? So second step, du dx. dx. This derivative is what? 1. Du dx is 1 over 1. What do? Cross multiply. What is this here? Dx. So this means du is dx again. So that was kind of nice. So when du is dx, that's an easy substitution, right? So notice what that becomes, right? This is, the constant 3 is there. 1 over u squared, and this is now du here, okay? Three, integral u to the minus 2 du. This is now what we integrate. So what's negative 2 plus 1? Negative 1. Okay, power rule. You guys get that there? So look at the constants. This is going to be really negative 3 now times 1 over u plus c. I'll give you every detail. Negative 3 over u plus c. What was u to begin with? X plus 1. So final answer. Negative 3 over x plus 1 plus c. There you go. Because this is what u was. It's x plus 1. Okay, so I decided to write or go over a whole other set of problems to get you guys started on USub. Right, we're going to see how this one pans out too. Remember, what is u? It's the inside function. So I'm going to share with you guys, you could do this way, right? You go straight to this if you like. It's not a problem, right? So u is 1 minus 4x. Du dx is d dx 1 minus 4x. What's that derivative? Isn't that negative 4? du dx is what? Negative 4 over 1. Here we go. Cross multiply, and what do you guys get? You get what? du is negative 4 dx. Divide both sides by negative 4 because you are solving for dx. Cancel here, okay? So you have all of this information. I can share with you guys here how you can do this. This is kind of interesting. So notice what I did. I didn't pull out my constant yet. So I left the constant of 5, u to the third power, and dx we know is du over what? Negative 4. Is that right? So here's what I'm going to remark to you. You can do that. You don't have to start by pulling out that constant. You can pull out the constant now, though. And that constant's going to be now what? It's just negative 5/4 integral u to the minus 3, right? Maybe you said, I'm not ready to see that power yet. I want to see how you pulled out those constants first. All right. Negative 5/4 u to the minus 3 du. Okay? So now, what do you guys do? You get to do your arithmetic. Power rule. You just have to know what negative 3 plus 1 is. What's negative 3 plus 1? Okay, so this is power rule. Now you just do your arithmetic here, right? So a negative times a negative, you get what? Isn't that going to be 5/8? Is that right? And you got u to the minus 2. Isn't that 1 over u squared? Okay, you guys okay with that? So I'm doing my arithmetic. Don't forget what u is. It's 1 minus 4x. So you get 5/8, 1 minus 4x squared plus c. Okay, you guys okay with that one? Let's see if we could do one more. Because I think I did, when I wrote this stuff yesterday, I did like 30 questions. I go, I'm going to do 30 examples. And then the other worksheet has, I don't know, maybe another 30. I don't know. You got 60 examples to do your homework? I don't know. When I was a student, I had to do a lot of questions, ladies and gentlemen. When I was a student, yeah, I had to do the same thing, like I'm showing you guys now, okay? So, and I haven't got to the trig functions, and I haven't got to the definite integrals, but this is u. Three x plus 1, right? Then you say, I need du dx. So d dx. What's that derivative? You guys know this is 3. Is that right? Okay. So you get du dx is 3 over 1. You're going to solve for dx here. Cross multiply. Right? So what do you get? du is 3 dx. Divide both sides by 3 now, and you get what? d over 3 is dx. And that's what you were looking for. Okay, don't forget this is your u. All right, you guys okay with that? So let's put this all together. Let's do the substitution portion, right? Substitution portion. 5 over u to the 4th. And we forgot what dx is. Dx is du over 3. Five-thirds integral 1 over 4. Okay. And integrate this. So we get, well, I'm going to do the -4 power. Okay. I'm going to share with you guys all the details I know I had to do as a student. What is -4 plus 1? Isn't that -3? Is that right? Positive times a negative is a what? Negative, and that's -5/9. Okay, and that's now 1 over u to the +3 here. Okay, so you say that's -5 over 9 u to the +3 plus c. We just have to remember u is 3x plus 1, ladies and gentlemen. 3x plus 1. So, okay, let's get the final answer here. -5 over 9. 3x plus 1 cube plus c. Ladies and gentlemen, here you go. There it is. So I know I made the best decision today to be here with you guys going over U sub because, the worst thing you could ever do or ever say to yourself, it's sad that people are saying you can't do this work. It's a waste of resources. It's a waste of time. We're not going to pay for it because that's what they're saying. If you want to learn it, some of these things you're going to have to pay for it yourself. That's what this is about. I don't believe that because I know if I was a student going to school today, I would not go to college because I could not handle that situation. I started in, like you guys know, I started in geometry, 120 here, so I needed all that. Then took 125 and so on. So, just to let you guys know, the thing about that is you never let anybody say you can't do anything either. And you never tell that to yourself. You put yourself in a position to succeed. Do that homework every day. Do the details like I've done. I've done every problem the same way virtually here without skipping steps. I mean, I showed you an alternate version about pulling out the constants at the end, which we did. Those constants are there all the way through at the end. But, this is what you do to do well, and you can do that. Just got to make sure you don't tell yourself that you can't do something. So anyway, so we're going to continue tomorrow with more U-sub because it's that important. In fact, like I said, I made this worksheet yesterday, and I could have just said, I'm going to go over, because that's what I was going to do. I'll go over what I already did, but I just kind of decided, it might be fun to, this is what's already there. So if you said, I need to see some more of those questions. Well, I did the same thing here. You guys see they're very similar, right? You're going to see a lot of similarity here. And I do have a video here. Integration by substitution. So you can see this was done 3 years ago. Only 5 likes. And it was about almost 3 hours of my life. Only 5 likes. And it's going to save people's lives in substitution. And it was free. But come back in a year or so, you may be having to go to a private school to get information, and it won't be free. It'll be thousands of dollars. And that's what you guys are facing. That's the messed up thing you guys are facing. So, anyway. Okay, we'll see you guys tomorrow. And we'll go over some more USub. Get started on the homework, because didn't I put the homework online? I think so. Go to the assignment portion. If you guys didn't know, on homework 3, 5.5 is USub questions. Try that out, ladies and gentlemen. We're going to work more examples tomorrow. So take care, stay safe, and enjoy the day. Final. This is going to be on your test 4, and this is going to be what you guys see in Calculus 2 and Calculus 3. You're going to see U substitution. Okay? Now, I'm going to skip a little bit more because I got up to like 14 or 15 or something. So I'm going to start doing some of these because I've had students say, hey, I know how to do the others, but how do you do some of these trig versions? Now, remember, we're using an inside-outside function concept, right? And you can think of this in some ways, right? This inside function, this is composition of functions. That was always your U. Just like for chain rule, it's the same exact idea, just like chain rule. So the inside function is between the parentheses here, okay? Like if you had to work with chain rule. So, okay. All right, so you say, do we start with, let me move this now. Do we start with U equal to 2x? And yes, that's the inside function. You guys okay with that? And then that's your first step again from yesterday. Okay, now what did you do for the second step yesterday? Do you guys remember? You always find du dx now. And that's differentiating u with respect to x. So what's this derivative? Do you guys know what that derivative is? I might have to stand today because I'm getting this weird pain in my leg. This is 2. Where's my water? Okay, you guys okay with that? All right. And you can say, is that 2 over 1 as a proportion? Yes. So what do you guys do with this now? What do you guys do? What does this become? Do you guys know what this is? Isn't this saying what? du is 2dx. Don't forget we're doing what? Solving for dx. So what do? Divide both sides by 2. Okay? So you say, oh, does that mean du over 2 is dx? It does. So I have my dx. It's du over 2. Okay, so what are we ready to do now? Step 3 with this again. What was step 3 from yesterday? Step 3 was to now what? Substitute. Is that right? Okay. So what do you have here? We have the integral sine of u, and we just found r dx. It's du over 2. And again, you guys know, what do I do with that constant? We pull it out. You get 1/2 integral sine u du. Okay? So you're now going to integrate what? Sine. Okay? What's the integral of sine? You guys know what that integral is? It's minus what? Minus cosine. Okay? And don't forget to add that c at the end. So you say this is minus 1/2 cosine u plus c. We're almost there. We just have to remember what u is. Is that right? And what is u, ladies and gentlemen? 2x. So go back and plug that in here. You say, do I plug in 2x? Yes. Final answer in back of the book, you're going to see 1/2 cosine of 2x plus c here. And there you go, ladies and gentlemen. This is how we answer number 17 here, okay? And let me do something here and say, okay. Yeah, there we go, number 17. And I think I'm going to give you guys a note on this one here, okay? So I'm going to go back, I'm going to do some erasing here. And I'm going to do something here. This is a note. I'm going to say, what if they gave you guys limits? Like they said, here's 0 to 2 pi. Or maybe just 0 to even just pi. They gave me some limits, okay? Now you have a what? You got a lower limit, and you have a what? Upper limit. This is now what we call an is that indefinite or definite? It's a definite integral. Sorry. Let's write that down. So if they gave you limits, just as a note, they didn't, but if they did, don't forget, this is a limit in terms of x. X is 0, x is pi, okay? Now, you still go through your u sub. U is 2x, you find dx. Okay? You got all this information right up in here, but what you're going to have to do now is this. You need some new limits, ladies and gentlemen. Your limits in the original question is in terms of x. You converted this integral in terms of u by u substitution, okay? So the question's going to be now, what are my limits in terms of u? I need a lower limit for u. I need an upper limit for u now. Okay, you guys okay with that? So then you go, well, how do I find my new limit? So this is where we're at. Well, go back over here. I'm going to erase this here. We know where it came from. And I'm going to focus here. We know where dx came from already. I'm going to focus on this representation of u. U is 2x. Okay? Now, if I plug in here this first value for x, remember my lower limit x is 0 here. I'm going to plug in a 0 here. What does my new lower limit become? That's 2 times 0. We know what 2 times 0 is. 2 times 0 is what? 0. So here's my new u. U now is 0. That's the new lower limit. So you got to convert the limits as well. What's the new upper limit? Right? What if you said, okay, what do I plug in now? Plug in pi. So you plugged in here 0 for the new lower limit. You got to plug in the value for x being pi. What is 2 times x? Do you guys know what that is? We're now going to get what? This is 2x. This is my new what? Upper limit. It's in green here. Okay? So now this will be simply what? 2x. So the moral of the story is you convert your limits with the u. Because u is in terms of x, so you're changing the x variable you're changing the x variable to a u variable. So now you say, is this going to be what? 0 to 2 pi? And I'll say yes. And you say, well, what changes now? Well, this is what changes. We now have what? You have to evaluate this from u is 0 to u is 2 pi. Okay, so we no longer have this version here. This is how it's different. We got a lower limit in terms of u, and we have the upper limit in terms of u. Lower limit, upper limit. This is the antiderivative, right? You say, is that simply just minus 1/2? Yes. Okay. That's the antiderivative in terms of u. So you guys know this is going to be the difference. U now of 2 pi minus f of 0 here. 2 pi, here's what? U. So what do you get? Minus 1/2 cosine 2 pi minus 1/2 cosine 0. Because this is my upper limit, and then this is my what? Lower limit. Okay? So do you guys happen to know what's cosine of 2 pi, by the way? Isn't that 1? What's cosine of 0? Isn't that also 1? So negative 1/2 times 1 is 1 minus a negative 1/2 times another 1, which is 1, I guess. So I can leave it like that. And we get what? Negative 1 plus 1/2. This equals 0. Could that be right? I think it is. So, okay, sine of 2x from 0 to pi is, in fact, 0. Okay? So an equal area is above the curve as it is below. Sine of 2x from 0 to pi. I mean, I might even go, since I've been working with Desmos all morning, we say y equals, is that sine 2x? Can't remember. And then this is from 0 to pi. So where is this 0 less than x less than 2 pi? That's supposed to be less than. Okay, I think we're supposed to close this. So you might say, what are you doing here? Well, here's my point. Was it from 0? Oh, it was 0 to pi. I apologize. You say, what's your point, Mr. Judge? Don't we see from 0 to pi for sine 2x an equal amount above the x-axis as below the x-axis? Don't we see that in this? Yeah, so that's why the area is what? That's why the area is 0, so you guys can see that there. Anyway. Right? You guys see what I'm saying? We graph this function from 0 to pi. The curve, half the curve is above and below, and it's symmetric. So makes a lot of sense. All right. What do you guys think about this next one? What's u going to be here for this next example? Inside function. Inside function is what? It's 3x. From composition of functions. Okay. First step. Second step. du dx is what? d dx of 3x. Isn't that going to be 3? Okay. And that 3 over 1. So du dx becomes 3 over 1. You're supposed to now solve for what? Supposed to solve for dx. Is that right? How do you guys do that? You cross what? Multiply. What do you get? du is 3 dx. Divide both sides now by what? By 3. What do you guys get for dx? I like putting my dx on the left. This is now du over what? Over 3. Okay, you guys okay with that? The integral of sine of u, and what's dx? du over 3. So the constant now is 3 to pull out, right? It's actually 1/3 because it's in the denominator. So you end up with 1/3 integral sine u du. Don't forget that constant's down there here. Okay, you guys okay with that? All right, what's the integral of sine? Can you integrate sine? Is that minus cosine again? Okay, so it's negative 1/3 cosine of u plus c. But don't forget, the question was in terms of what? X. So you're going to have to convert back. You're going to say u, we know, is 3x. We already know that. Okay. So put the u back as 3x. You got the final answer. Negative 1/3 cosine 3x plus c. There it is, ladies and gentlemen. There you go. Okay. What do you guys think? Is that okay? Is that just like what you've been doing? If it's a square root or you have this to a power, it's the same thing. All right. This shows up sometimes. Cosine of pi. You guys know pi is a constant, right? Pi is not a variable. So again, you let u be that inside function, which is pi x. Okay? Right there. That's your u. Again, the second step is always define du dx. So you have d dx of what? Pi x. Didn't we say pi is a constant? So this is just going to be what? Pi. Pi is a constant, okay? And you can write that as a proportion again, like we've been doing. Pi is just a symbolic number of approximately 3.14, blah, 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 right? Now, what do we do with this? Cross what? Multiply. So that means du is pi dx. Don't forget. The whole idea is to solve for dx. So you divide now both sides by what? By pi to get cancellation. And what do you get? Dx is what? Du over pi. We found dx. Let's substitute. What do we get? Integral cosine u dx is du divided by that pi we just found. Another constant to pull out, right? Pull out the constant. What do you guys do with that constant, right? It's out now. Do you guys see it? So what's left? Antiderivative of cosine. It's going to be what? Isn't that just sine? Yep. And at the very end, don't forget to add your c again, okay? You're almost there, almost there. You just have to go back and find what u is. What was u? We said u was pi x to begin with. Don't forget that. We got to put it back. If the integral is in terms of x, the answer is in terms of x. So this will be 1 over pi sine pi x plus c. $19 here. Now, I'm just going to remark again. You always have these remarks. What if they gave us a definite integral? -1 to 1. Okay. No, notice something here, though. What if they did that? If I can get back here. I can do a couple of things here. You know what I can do? What do we know? Let me find a nice color again. I don't even know. I'm out of colors. Pink. If we're awake, what do we know about cosine? You don't know anything about cosine? Cosine's an even function. Is that right? Isn't cosine even? What do you guys know about even functions? Isn't this a symmetric interval? Okay. Then we can turn this into what? 2 integral 0 to 1 cosine pi x dx. Because of the fact that cosine is a what? Even function. Remember that property I gave you guys? Okay, now go back. I know you guys already know how to get that dx stuff, so I'm going to erase this here. We're going to do our u substitution again. But as you guys remember, what happens here? I have to convert. This is what? My lower limit x is 0. My lower limit x is 1. Okay? So I got the lower limit and I got the upper limit. I need limits now in terms of what variable? I need them in terms of u. This will be u equals. This is u equals, because we said u is pi x. So we're going to plug in what? 0. And what is anything times 0? What's pi times 0? 0. Okay, you're going to plug in 1. What's anything times 1? Itself. 1 times pi. Is that right? 0 times pi is 0. So I have new limits. We got to convert the limits to. Okay? And so you say, is that what this becomes? Yeah. And this will be what? 0 to pi. That integral. And you say, well, what happens with this? Let's erase everything. This is now a definite integral. Let's see what this is. It's still 1 over pi now. Antiderivative of cosine is sine, but now it's from u is 0 to u is what? Pi. Lower limit is orange. Yes, or yellow. I don't even know what that is. Green. Antiderivative right here is sine. So we need f of pi minus f of 0. Don't forget what? We're forgetting an important detail. I'm going to have to find a color. Yellow? Don't forget the 2. There's a 2 here. Okay, there's a what here? A 2 here now. There's a 2 here. Because when I use that fact about a symmetric interval, there's a 2. It's double now. Okay, so now we're good to go. So this is going to be 2 pi. Don't forget, you have to apply your limits, right? Green, orange. 2 pi sine pi minus 2 pi sine 0. Do you guys know what sine of what? What's sine pi? I think that's 0 as well. Is that right? Sine 0. This is also 0. Jeez. Getting a whole bunch of zeros. 2 pi times 0 is going to give you 0. 0 minus 0. So it looks like, again, we have a similar situation here. Final answer 0 here. So negative 1 to 1 cosine pi x. So an equal amount of the curve is above and below over that interval. You say, can you show me in Desmos? Let's look at Desmos. And I'm going to do this. I'm going to change this. I'm not. Y equals cosine pi x. And the interval is going to be now, where's that interval? Is it negative 1? Yeah. Negative 1 less than x less than, oh, how come it doesn't do? I guess shift x and here's my point. Because of some symmetry properties there, right? Looks like between negative 1 and negative 1/2, you got a certain area below the curve. 1/2 to 1 above the curve. Looks like that those two areas below the x-axis are countering the area above the x-axis, just so you guys can see that there. So it looks like the area is 0. Okay, let's try number what? Do you guys want to try this one? Give you guys a few minutes to try this on your own. Should I change it on you and add some limits? Yes, I'm going to give you guys some of this. I'm going to say 0, 2. I'm going to change it on you guys. 0 to pi over 2. Give you guys some time to try this yourself. Of course, we'll go over it. And let's see what you guys get. All right, ladies and gentlemen, let's take a look here. You start with the inside function u, is that right? Okay, so we say, okay, u is 2 pi x. So I would say go to your now du now, right? So you say du is the derivative of 2 pi x. Isn't that 2 pi now? Pi is a constant, ladies and gentlemen. Create your what? Create your proportion. Cross multiply. So looks like du is 2 pi dx. Remember, you're solving for dx here. So since you're solving for dx, divide both sides by 2 pi here. So at the end of the day, you're going to get what? Du over 2 pi is dx. Okay. So, all right, you might say, okay, what do we do with all this information, right? Well, don't forget, there's another small piece. This means x is 0, and this means x is pi over 2. So when we create or we substitute here, yes, it's cosine u. Dx we know is, right, du over 2 pi. If u is, or x is 0, that's 2 pi times 0. What does that mean about u then? Your lower limit is 0, so we're converting this first lower limit to this next lower limit. What about when, now the upper limit? X is pi over 2. So we got to know, is that right? Yeah, I get 2 pi times what? I guess it's pi over 2, is that right? That's weird. Pi squared. Is that weird? Something's bothering me. That, yeah, that looks okay. Is that right? I don't know. Am I losing my mind? What do you guys think? Did I make a mistake in my arithmetic? Two pi and then x is pi over 2, so it looks like it's pi squared. That's kind of odd. Integrate from 0, pi squared cosine u d over 2 pi. Pull out your what? 2 pi. That's 1 over 2 pi. You integrate from 0 to pi squared cosine u du. Now, what do you guys know? We're going to have to do this right here, right? This becomes 1 over 2 pi. It looks like it's sine u. Evaluate it from 0 to what? Pi squared. Is that right? Okay. So f of pi squared minus f of 0. And we say we have 1 over 2 pi sine pi squared. 1 over 2 pi sine 0. What's sine 0? 0. So my final answer is going to be, it looks like it's this over 2 pi sine of pi squared. Okay. Never seen an answer like that. I'm just trying to figure, did I make a mistake? 0 to pi over 2. Cosine 2 pi x from 0 to pi over 2. It looks like we're fine. We're converting. Okay. All right, that's fine. Now let's try this one here. We're going to integrate what? Secant squared x minus 1. You guys know, let u be the what? Let u be that inside function. So u is x minus 1. Du dx. Differentiate x minus 1, and that's 1. You'll find, again, this is that situation where du equals what? Dx. So I have all the relevant information here to convert in substitute. So this becomes the integral secant squared u, not dx, but now what? Du. And what does that integral become? Do you guys know? What's the antiderivative of secant squared? Isn't that tangent? Okay. And what is u? Yeah, we already know what that is. So this will be tangent of x minus 1 plus c. Final answer, ladies and gentlemen. Easy breezy, lemon squeezy. Then they give you this one. That looks similar. It's just this time, what is our u? Right, u is going to be now, it's that inside function. U is 2 minus x. Okay. What's the difference between this one and the last one? That when you differentiate u with respect to x, ladies and gentlemen, you get now -1. Is that right? -1 over 1. You're trying to solve for dx now. Cross multiplication. What does that give you? Du is minus dx. Divide both sides by that -1. And you get what? Negative du is dx because you have cancellation. This is a -1, -1. So we got two things here. There you go. So let's convert. Secant squared u now. What's my dx? Do you guys know what dx is? We just found it. It's minus du. Okay. So here's what we get. Minus integral secant squared u du. Okay, so again, we're going to integrate this portion. Don't forget the constant here that you pulled out was that -1. So you already seen from the last example, the integral of secant squared is tangent. This is minus tangent u plus c, okay? We just don't want to forget what u is. U is what? 2 minus x. So my final answer, negative tangent 2 minus x plus c. There you go, ladies and gentlemen. So here it is. Use substitution. Isn't that kind of very similar to the stuff we seen yesterday? It should be the same, very similar. Okay, let's try this one here. This is kind of interesting. Okay, you notice this is the same. You're going to probably suspect, this is the integral of going to be secant, right? So that inside function, what's in the parentheses, is pi plus 2x. You do the same thing. Differentiate u with respect to x, and that's going to be dx of pi plus 2x. Do you guys know what that derivative is? Isn't that just 2? You can put that over 1 cross what? Cross multiply. Get your dx. So we get du is 2 dx. Divide both sides by that 2. What do you get? Du over 2 is what? Dx. That's the dx we just found. Okay, so let's substitute now. You say, that's the integral of secant of u, tangent of u, dx is du over 2. And here's my constant. I can pull that constant out. 1/2 secant tangent. And then you might say, you should know what's the integral of secant tangent. Secant, yep. So it's just be 1/2 of secant u. And all along, we never forget what u is. It's pi plus 2x in this case. So you plug that in. 1/2 secant pi plus 2x plus that c here. And I'm going to go let me try. Okay, I'll try that one. This is kind of interesting. This is just like the last one. But this is the first time we've seen this in 24 here, right? You say, what do you mean? Yeah, I guess when I wrote this, here's the fractions. So u is going to be x over 2. I want to kind of emphasize that here. This is the u. And we'll see how this pans out, right? I want you guys to notice this. This is now du dx. So you differentiate u with respect to x. What's this derivative? Do you guys know? What do you think happens here? This is a constant. I could pull out my constant. Isn't that 2 a constant? So this is just the derivative of x, which is 1. What I'm saying, ladies and gentlemen, is this is 1/2. Okay? Oops. So that means now the following. Du dx is 1/2 now. Cross multiply. What do you think you get when you cross multiply here? You get what? 2 du is 1 dx. You already have it solved for dx. Okay, you guys okay with that? This is already solved for that. So now, what do you get? Secant what? Tangent. What's dx? Dx, ladies and gentlemen, is 2 du. So my constant is not in the denominator. The constant is in the numerator. So pull out the constant. And again, you got secant tangent now, if you pull out that constant. Okay. And what does this give you? That's 2 secant u plus c. Is that right? So now we've seen a version where u now, what was u here? U is x over 2. So u was a fraction. That's fine. So final answer, 2 secant x over 2 plus that c. There you go. So just don't forget, it did have that constant there. The constant is 2. And now this is kind of a different kind of classic questions because it's still u substitution, but you have kind of like a product of two functions here, okay? Now, you look at this detail in Calculus 2 comprehensively, okay? So there's kind of a way, these are the first kind of questions. So in Calculus 2, you do have to know how to do u sub. But here's what I'm going to say. You approach it differently. Because if you look at this, you might say there is no inside function. Right? You go, there's no inside function. I'm used to 2x, x over 2, or whatever. Well, it's still u sub. Let me share with you guys what that is. Let me try to find it. I'll use red. If you see sine, or even cosine, to a power here. See that power 4? Sine to a power 4. You're going to let u be sine. I'm going to show you why. You say there is no there is no inside function here. So these are the kind of questions that some students are coming to me and go, Mr. Judge, how do you do this? And I said, I'll show you tomorrow. Okay? So far, what you're going to have, if you notice, I'm not saying substitute now. That's actually u to the 5th power. You guys okay with that? And yes, I know you have that cosine and you have that dx. Let me show you how nice this is, okay? Because remember what step 2 is? You differentiate u with respect to x. Now, what's the derivative of sine? It's cosine. And you say, can I write that as cosine over 1? Yes. So your steps are exactly the same. Nothing's different. You're trying to find, again, like you have before, dx, just like before. Okay? Now, notice what you get when you cross multiply, though. You get du times 1, which is simply what? Du. You get cosine dx now. Remember what you're trying to do? You're solving for dx. Remember, we're always solving for dx. What do you have to do now? Do you guys know? You divide both sides by what? By cosine. You're solving for dx. What does that give you? You get du over cosine x is dx. Okay? So this is what you end up getting here. So you're getting this, and you're getting this. And you say, what does that have to do with anything? I'll say it's everything. This is my dx. Okay? So go back now and remember, what do you do here? You replace dx with what? Du over cosine. So this portion gets replaced with du over that cosine. What do you think happens with this cosine? Gone. Cosine will cancel. Cosine goes away. So you have at the very end the du. This integral is just simply going to be the following here. Let's get the right color. It's u to the 5th du. Huh? Oh, sorry. It's not the 5th. Thank you. I'm doing 3 things at once here. It's not the 5th power, it's the 4th power. I apologize. Good observation here. Okay, now I make the claim. You guys know how to do this. You use the what? Power rule, right? It's 1/5 u to the 5th plus c. Power rule. But u, we know, is what? Sine. U is sine. Final answer. 1/5 sine to the 5th power x plus c. There you go, ladies and gentlemen. Easy breezy, lemon squeezy. So, you know, you have these kind of powers of sine, and you'll see powers of cosine even. You know, oh, there we go, a power of cosine. And you say, hey, Mr. Judge, you do this the same way? And I'll say, yes. Okay. You see this cosine, and you see that power 3. So u becomes cosine here. Okay. Same exact process. The derivative du dx, that derivative of cosine, do you guys know what that derivative is going to be? What's this? Minus what? Sine. Put that over 1. So you might say, why is that over 1? Because you're going to solve for dx. Okay, you create that proportion so that you can solve for this dx here. And so now multiply. Du times 1, isn't that du? And then we got minus sine x dx by cross multiplication. Right? So what are we trying to solve for again? The dx. How do we do that? Divide both sides by minus sine. Cancel, cancel. So I get minus du over sine becomes that dx. And yes, your u to begin with was what? Cosine. So now it's the substitution again. Okay? So let's take a look at this in detail. The integral u to the 3rd power. What's we got? Don't forget, you got that sign. That's still there, okay? But we have to find out what dx is. We know what dx is. You say, what is dx? It's right here. It's minus du over sine. Okay. So, minus du over sine. This is what you get by substitution here, okay? Now, a few things are happening. Yes, you have a constant, and you get to get rid of the factor of sine there because it's on top and bottom. And these problems are very specially chosen so that happens, ladies and gentlemen. It's going to happen. So now altogether, what are you left with? Notice what you have altogether, right? Maybe we'll get pink. I don't know. U to the 3rd, the minus sign into u. So you're going to get now minus the integral u to the 3rd du, because again, -1 is a constant here. Okay, you guys okay with that one? I make the claim you guys can integrate. You need the antiderivative of u to the third by power rule. So it's 1/4 u to the fourth plus c. Okay, and remember, or u is cosine. We already started that here. U is cosine. That's how we started that process. Okay, so it's a little different. There's no inside function. So final answer is going to be negative 1/4 cosine to the fourth plus c. Because that's what u is, cosine. Anyway, ladies and gentlemen, let's take a look at this here. I don't know. I must have gone through at least 23, 24, 25 examples. Oh, I want to do this one. Sorry. Let's get this one done. There's an inside function. This might even be on your test and final. See how there's an inside function? What do you let u be here? Let's get this one. U is the square root of x. Glad I checked this. What's du dx? Remember I told you guys? Memorize that derivative. This is a derivative. Remember this one? This is x to the 1/2. You're going to get 1/2 square root of x. Now this is already a proportion here. Okay, remember that was this derivative. So when I try to solve for dx by cross multiplication, 2 square root of x du is 1 times dx. This is just simply what? Dx. So you have dx. You have u. What do you do with this stuff? You substitute, okay? So you got the integral of cosine u. This is the square root of x down here, still there. We didn't do anything with that. You see what I'm saying? But what is dx? When you solve for dx, what did you get? 2 square root of x du. Okay. All together. 2 square root of x du. What's going to happen with this square root of x? Anybody know what happens? It what? Cancels? See what's going to happen? That square root of x cancels. It went away. You thought, wait a minute, what do I do with that? Don't forget you got a constant 2. Cosine u now, this is du. But your constant 2 is here. I'll put it all the way down. Can you guys integrate that? What's the integral of cosine? So the derivative of sine is cosine. So that's sine u plus c, ladies and gentlemen. Okay, what is u? U was the inside function for cosine. So it's the square root of x. Final answer, 2 sine square root of x plus c. And, ladies and gentlemen, glad we went over this one too here for number 27. I must have given you probably about 25 or 24 examples here. You guys can try this one out too. Should we get it done? Inside function. What's in the parentheses inside? U. Okay, you see that inside function? I know you have this power 4. Let it be that inside function. You say, what's going to happen with the x squared? It's going to cancel. right? It'll cancel because we look at this as du dx. We differentiate with respect to x. 1 plus x cubed. What do you think that becomes? 3x squared, right? So you put that over 1, and you say du dx 3x squared over 1. Remember, we're trying to solve for dx. Nothing's changed on us. This process is exactly the same. So this becomes du 3x squared dx by cross multiplication, solving for dx, dividing both sides by that 3x squared, gone and gone. Okay. So what we found was what dx really is. And I can write it this way. It is du over 3x squared. This is what we're looking for. Okay? We know what's going to cross out. Now, I'm going to put every detail here. Like, you guys see this. Just write down what you see. We have the integral of x squared. Okay? That term is here. But the next term is u now to the 4th power. Okay? And you say, what's going to happen with my x squared? It's going to cancel because we got the dx. Dx is du over 3x squared. So sometimes people look at that and say, that's 3, what was it? It's du over 3x squared. Sure enough, what just happened? That's the same x squared, ladies and gentlemen. Gone. Yes, you have a what? Constant 3. You pull out the constant and you get what? 1/3 integral u to the 4th du, ladies and gentlemen. And this is what you integrate now. Okay? So we know what that is by the power rule. That's 1/5 u to the 5th plus c, which gives you 1 over 15 u to the 5th plus c. Okay? So we can integrate it, but we'd also want to remember what u was, because we're going to put it back. U is 1 plus x to the 3rd power here. So it is going to cancel. And so, ladies and gentlemen, 1 plus x to the 3rd power, raised to the 5th power, plus that c. So I'm glad we did this question as well. Final answer, ladies and gentlemen. So hopefully you guys can do your homework on what? What's this section? U sub, section 5.5. And again, you guys know on my website, I do have additional resources for you. If you said, boy, I think I'd like to see some more U sub, well, I do have a tremendous amount of different examples for you. Right here, integration by U substitution. In fact, the video presentation is right here. So there's an additional, very similar questions that we already did for you, if you guys want to see additional examples, okay? If you need that. Whew. Must have probably, how many is that? 25 examples here with us in 2 days, and probably another 20 examples there. And then you got 45 there, and then whatever, 5 or 6 examples in your book. You should be good to go, ladies and gentlemen. All right? You guys okay with that? And so I'll see you guys Monday, a half hour early if you care. And you guys can get started early. Okay? You got your study guide? There you guys go. Okay. Take care.